Here we go. We're going to start off with the hard stuff, surface area. I think I fixed that. And then we'll do some volume. So learning target 1, SA.1, excuse me. So to find the surface area, we have to find the lateral surface area, which we do by finding the perimeter of the base and then multiplying by the depth of the shape. So the perimeter of the base is going to be 9 plus 9 plus 13 plus 13. Which is going to be 44. So the perimeter of the base is 44. And then we take that 44 and we tiny tower it up to the top, and that will find all of the faces for me. So 44 times 12. So the lateral surface area, which I actually didn't ask for here, is going to be 528 centimeters squared. And then I have to add on the top and the bottom, which the top and the bottom are going to be two rectangles. So it's going to be 2 times 9 plus 13. Or sorry, 9 times 13, which is going to be 117. Times 2, add them all together, plus 528 equals 762 centimeters squared. Lateral area for cone is going to be pi RL. L is going to be that right there, the slanty part of the cone, which makes sense because we're looking for surface area, so we have to use the outside surface. So pi times R times L, which is 50, gives me 50 times 14. I'm going to keep everything in terms of pi, so that's going to be 700 pi. And then the total surface area is, I'm going to take the lateral area plus the area of the base, because this is a one-based shape, so the area of the base is going to be a circle. So it's going to be 700 pi, which is my lateral area, plus pi times r squared. That will be my total. So 14 squared plus 700 is going to be 896 pi. And then my units are going to be inches this time. Boom. Moving on. The lateral surface area. So again, what you need to do is find the perimeter of any two-base shape. Find the perimeter, and then tiny tower it up, multiply by the depth. So the perimeter of this circle, the radius is going to be 9. So the perimeter is 2 pi r, also known as circumference. So that's going to be 18 pi. Take 18 pi and multiply by 20. That's going to be 360 pi centimeters squared. And then the total surface area, you're going to have to add on the base, which is going to be 81 pi, pi r squared up top. And then pi r squared on the bottom is 81 pi as well. So I do 360 pi plus 2 bases on this one, 81 pi. 360 plus 81 equals, I'll probably do that in my head, 522 pi. And my units are centimeters squared. This one's tricky. Everyone's going to find the perimeter of what they think is the base. Annette, bad math alert in the chat. That is not the base. The base of this shape is going to be that triangle. So let's find the perimeter of the base real quick. The lateral area is going to be the perimeter of the base times the depth. So the perimeter of the base is 18 plus 41 plus 41. That's going to be 100. And then times the depth, which is 12. So that's going to give me 1,200 millimeters squared. Again, that tiny tower it up. Find the perimeter of the base, which is a triangle, and then tiny tower it up. To find the total surface area, think about it, you have to add the two triangles. So we need to do a little Pythagorean theorem here. This is 18, 41, 41. This is actually, you could do Pythagorean theorem, but some of you might know that this is a 9, 40, 41 triangle. So to find the area of the triangle, area is going to be equal to 1/2 base times altitude or height, which is 40, That gives me 1/2 times 18 times 40, 360. And then I need to take that and multiply by 2 because there's 2 of them. There's the front triangle and the back triangle. So that's going to be 720. So the total is going to be 1200, which is the lateral, plus the 2 bases, which we just found, 720, gives me 1920. And my units are millimeters squared. I wonder why I changed color halfway through. All right, we're doing pretty good. Here we go. These two are tricky. These two are the toughest ones in the whole problem set, volume or surface area. So to find the lateral area, it's going to be perimeter of the base, which is going to be, how many sides does it have? 1, 2, 3, 4, 5, 6, 7, 8. Oh no, it has 8 sides. So it's going to be perimeter of the base, which is 8 times 8, 64, times the depth, which is 10. So that's going to be 640. Now, the tricky part, there's 2 bases. Area of the base is going to be equal to 1/2 apothem times perimeter. We know the 1/2. We don't know the apothem. We do know the perimeter. So we got to find the apothem. And that's tricky. So I'm going to draw this triangle for you. I'm going to draw it down here. I guess I'll draw it right here. We got to figure this triangle out. Make sure your calculator mode is in degree mode, unless you want to get it wrong. So this is 8. The bottom's 8. When I drop the altitude or the apothem down, which I'll draw in green here, when I drop this down, that's going to make this 4. Now I need to find out how big this angle is. And the way I would do it is I would say, well this is tricky. Think back to our last chapter. Because there's 8 triangles, I should be able to draw, or there's 8 sides, so I should be able to draw 6 triangles times 180, which is 1080, and then I divide by 8. That'll give me how big each angle is, 135. So this and this angle are 135. So I have to divide by 2, which is 67.5. So I just found that angle to be 67.5. Look back in your notes from chapter 10 if you forgot how to do that. So now this is opposite, this is adjacent. I'm going to use tangent of 67.5 equals opposite, I'll call it x, over adjacent, which is 4. Multiply by 4 on both sides. 4 tangent 67.5, 9.657. And that's my apothem. So I can just do that times 64. Divided by 2. Each base is 309.019 times 2. So it just kind of undoes itself. So the total surface area is going to be the lateral area plus the 2 bases, 618.038672 plus 640 gives me 1258.039. And my units are centimeters squared. Sorry about that one. That was a crazy one. We're still at 9 minutes. I want to keep all these below 15 minutes. Last one. So this one, we need to find the slant height. So again, careful at the lateral edge. We don't care about the lateral edge. We have to find the slant height. So the slant height is going to work like this. It's going to work perpendicular. It's the altitude of the face. So if you think about it, I'm going to draw, I'll color code it for you. The true height, or the altitude of the shape, we call it the true height, is 10. we're looking for this little green slant height. We don't know what it is yet. Don't use the lateral edge. Don't use it. Sharp. And then this we know because the bottom is a cube, or the bottom is a square. This is going to be 6. Oh, undo. Almost made a terrible mistake. 3. It's only half. Nice. So now we can do Pythagorean theorem. This one's going to end up kind of messy. So we go 3 squared plus 10 squared equals x squared. 9 plus 100 equals x squared. So x squared equals 109, which means the square root of 109. Let's ballpark it. It's going to be 10.44. So I just found the lateral edge. So to find the lateral area, there is like a strange formula, but I just like doing the nets. So it'd be the area of all these triangles, and all these triangles are going to be the same. So the base is going to be 6. We just found the slant height to be 10.44. So it's going to be, one of the triangles is going to be 1/2 6 times 10.44. Which is 31.2, 31.32. And then I have to multiply that by 4 because there's 4 triangles. So the lateral surface area is going to be 125.284 centimeters squared. To find the total, I take the lateral. I'm going to undo the centimeters squared. Plus the area of the base, which is base times height, 36. 161.284 centimeters squared. 12 minutes, under 15. Boom.